Hello, everyone. We're going to do one final concept video today. No demos in this video. A little bit of a boring concept, but it is something that you need to understand what we will be doing going forward because this is kind of the final piece of the puzzle in object-oriented design. When we started this series of videos, we talked about why object-oriented designs, they're not the standard sequential way of doing things, right? We broke things apart, we created little modules, we created classes that have their own independent existence, they work on their own, you can test on their own, and you can put them together in a coherent functional system. Well, when you're running a system, obviously you're sequencing everything because there is finally that ultimate sequence, which is time, and everything has to follow the sequence of time. And that is an exact sequence. Yes, there are multiple things that can happen at the same time, but for most practical purposes, all your objects and everything that you have done, they will need to follow a strict sequence. So we're going to see today how the way we have been designing object-oriented systems, how they finally come together and run in a sequence. There are actually multiple types of models that go into modeling sequences. We're going to cover just a few of them in this the next 30 minutes or so. But the first one is the simplest one. It's the use case. You essentially what you do is you kind of break your system down into different cases, different parts that can be sort of independently working with each other. Now, here we are not talking about classes. We're talking about basically big blocks of the system that does something on its own. And you can kind of identify, okay, this is one functionality and it's a step-by-step description of how a user is going to use the system to accomplish his or her goals. Okay. And use cases are typically derived from system requirements. So if you have a project management um, system, for example, this is probably going to be part of that, overall process. So let's take a look at what use cases have and some of the interesting things that appear in use cases that we haven't seen so far are actors. Obviously, we have been building systems, but systems are kind of useless unless you have people, other systems, things that sort of interact with the system that you designed. And here they're called actors. And actors are basically participants. They could be living beings, they could be users, or they could be other systems. Today's day and age, you create systems that work with other systems. So you hear about web services, for example, in which case one system making a web service request to another system will be an actor in that case. There are different types of actors, like initiating actor, an actor that actually initiates the use case, and there could be other actors that are participating in order to complete the use case. They're called participating actors. And in a use case diagram, as well as in sequence diagram, we're going to be drawing stick figures. And that's pretty common. And in sequence diagrams, as well as use case diagrams, we draw these stick figures and we call them the actors. So this is a simple example of a use case diagram where you have some sort of a security door that maybe has a fingerprint sensor, or it could be like the keypads or any other kind of some sort of a security door that you're trying to open, and you have a tenant that could be the one initiating the process, or it could be the landlord, the person who owns the unit, initiating the lock or unlock. These two are our use cases. And in order for these use cases to function, this may include another use case that is doing some sort of an authentication. Obviously, in order to lock the door, you do not need to authenticate. In order to unlock, you will need to authenticate. And there are other actors that could participate. And notice that these guys are not necessarily people. Like this, there could be a device that is not part of the system, but maybe it is some sort of a hardware that you will need to attach sensors to decide if it is locked or unlocked. A switch, again, a hardware, some sort of a hardware unit that is participating to make this process work and so forth. So that's essentially what a use case diagram looks like. We're not going to talk too much more about use cases. The next thing that you would notice sometimes is called a scenario. A scenario is kind of a details of the use case. So here you're basically listing out who are the actors, what is the goal of the use case, what are the preconditions, what need to happen before this use case start, what are the post conditions, how would you know that the use case actually function. And then you list out the main events that occur for this use case to happen. So these, now here we are actually listing out in sequence the order of events that happen in this particular use case. And so that is called a scenario. And as you can see, sometimes they're called then diagrams, but scenarios are typically completely text-based. You're essentially writing something out with as much details as you can. No programming yet. It's essentially description that a tester can use to test your use cases. So now let's take a look at the actual topic for this video, which is sequence diagram. A sequence diagrams, as I said, it represents interactions of the various objects. So now we are going to start bringing our objects back into play. And what we're going to see is how these objects interact with each other, but in the sequence of time. So in what happens first, what needs to happen next, and so forth. But ultimately, they will need to collaborate to realize a use case. So ultimately, you will have maybe 3 or 4 or 5 or 6 or 10 use cases of a system, and you're going to create a separate sequence diagram for each of them. Creating a sequence diagram for an entire system is absolutely fruitless. As you would see very quickly, sequence diagrams tend to be very long and very wide. So building sequence diagrams for entire systems is absolutely pointless. So you only want to break it down into small use cases and distribute the behavior in these use cases. So why do we use sequence diagram? Well, as I said, we're adding details to the use cases, but more importantly, we show how the objects collaborate, and then we can get closer to design and see, hey, this is how these objects work together. Here's an example of a simple sequence diagram, and these guys on the top, these are our objects. So there's a customer object, stockbroker system, and securities exchange. And these are the messages that sort of go back and forth between the objects, which is how the objects work together. This is, of course, as you can see, from a textbook, but we were going to do a little bit more concrete example in a little bit. But before we do that, let's take a look at what are the different components of a sequence diagram. The first component, of course, is the active object. So before you design a sequence diagram, you need to look at what are the objects that need to take part in the use case. Okay. And you're going to put them from in a left to right sequence. There is no significance to what order these objects appear. You try to bring them in as you need the objects, but sometimes you reorder the objects to make sure there is not a whole lot of overlap going on between the messages. But normally you would always put the actors on the left and you add objects as they get involved and try to minimize crossovers. We're going to see what I mean. The first thing we need to know, once we know all the objects that we need, is we create the lifelines of the object. A lifeline is essentially the object on the top and a line, vertical line down, representing the object's life as time progresses. So time is progressing in this diagram from top to bottom. So at some point in time, the object will get created, and at some point it's going to get terminated or memory managed, whatever you call it. But at that point, the object will cease to exist. But that is the time during which the object is going to exist and it's going to interact with other objects. It might run the entire length of the diagram, or it may start or end within the diagram. And so it's entirely up to you. Typically, we underline the name of the object. Um, if it's a class, which we don't talk too much about classes in sequence diagram, we are actually working with the real objects. And you would see if you have multiple objects for a class that participates in a use case, you will need to create a timeline for both of those objects. So that is kind of important to know for sequence diagrams. The next thing we need to learn about sequence diagrams is messages. What is a message or an interaction? That's why it's sometimes sequence diagrams, these diagrams are called interaction diagrams. These are messages that are sent from one object to another. Now, if I ask you now, what is a message that goes from one object to another? You should be able to know that, well, the only way you send a message to another object is by making a method call. So whenever you're calling a method, you're basically sending a message. So for example, you have a light object, you want to turn it on, you're going to call a method called on, right? So you're sending the message on to the light object, and the light object does whatever it needs to do to turn itself on and respond back to you saying that, yeah, I turned myself on, something like that. So that's essentially what a message is. And we represent that by essentially an arrow that goes from left to right. And at that point, the object comes alive or becomes active, right? So typically, as you know, that in Python, when you instantiate a class, you typically instantiate all the objects that are part of the class. But in the sequence diagram, oftentimes, there are 5 or 6 different objects that a class is instantiating. You do not have to create all of them. You only create them as you send it the first message. So here are the messages. This is how you represent. So here is what I was talking about. This is the first object that got created. This object may have been created before, but we're going to start showing it on the timeline when it receives its first stimulus. So just by having it created, that's great. But in the diagram itself, when we send it the first message, that's when the object sort of comes alive. Here are the different types of messages. Now, not all diagramming editors would allow or support these messages, but it's kind of interesting to know the different types of messages you can send. We'll see that for most practical purposes, we are either going to use the synchronous messages or flat messages. And of course, whenever we need something to be returned to us, we'll use the return messages. Asynchronous messages are nice when you have things that could potentially happen in the background, but not all that common in sequence models. So a synchronous message is where you send a message to an object and you're waiting for that object to finish, and then you can do anything else. So this is where they're also often called blocking messages. So you send a message and you're stuck. You can't go forward until that message finishes. So for example, let's say you want to display something on a display that is slow and you're scrolling that message across the display. You can send it as a blocking message. Then what will happen is you're stuck until the entire message continues and scrolls through. And then the system tells you that, yeah, it's finished displaying. Now you can do something else. So sometimes you may have to think about when you send a message, is this going to take a time? Remember that there are certain types of things that you cannot wait too long for. A return message is, of course, something that is a reply to a synchronous message. And a lot of times that's not shown because if it's just a method call and that does not have any return value that you're interested in, just drop the return message and save some space on the diagram. An asynchronous message is where the sender is not waiting for a reply. It's basically a message that goes and you're just done. When something will happen eventually, but at least for now, I don't really need to worry about waiting for a reply. And flat messages where the sender sends a message, as long as it's gone good enough, we're never going to use the result. Maybe some sort of a logging message or something like that. The system is not all that crucial for the system to function. So here are a few analogical examples, you could say that, for example, a phone call is kind of like a synchronous message, right? So when you make a call, you can't really do anything until the person you called actually picks up. So that would be a synchronous message. This is something that you want to do when you want to do things one at a time and you can't go forward until the previous thing is complete. So here is an example where a teacher logs in to a web interface. So let's say that is your object that handles all of the logging in and things like that. Until I've successfully log in, I can't go and do anything that I want to use with the system. So I need to wait for the system to authenticate and validate me and provide me with the successful login. Then I can go and do additional things that I can do with it. An asynchronous message is where I'm sending a message and this is important, but I'm not going to wait around for to continue doing other things. I will need a response at some point, but I'm not going to wait around for it. So one similar in real life is kind of like a text message, right? You're sending a message out and you're kind of expecting the person that you have messaged to respond back to you, but you're not going to wait around looking at the phone screen for that message to arrive. So that is an asynchronous message when we do not want to wait for the response, but it is important to get the response back. So this is where we have been using what is called a callback handler, right? So for example, we want to use a button. I'm saying that the button has a handler and when I create the button, I assign a handler, and then I'm just continuing to my business until the button gets pressed. The button sends me some message saying that, hey, somebody pressed the button. Do you want to do something with it? So that's where synchronous and asynchronous messages differ. So in this case, for example, if you see that there are logging processes that's happening, these are happening asynchronously. So I'm not going to look for, you know, wait for these things to complete to continue, but it is something that is important. So maybe the audit guys who are looking at the system logs would require something to happen before you are allowed to use the system and so forth. A flat message is kind of where it is not something, it's sort of informational that you're doing, but it's not something that you're really looking for a response back, right? So these, for example, an email or an announcement could be considered a flat message, where you are not going to wait for a response, and also you're not necessarily going to use that response even if the receiver were to respond. So in this case, for example, an email with grades, which is obviously not going to be very FERPA compliant, but when I'm sending out messages saying an assignment has been graded, That's an informational message. Some of you may send me a new message with some information about, clarification on why you received a specific grade or something like that. But that is not something that I'm going to be waiting around to start grading other assignments, for example. So here is another example, but we're going to do some really practical example with an actual working system. But one thing to remember is that when you have these messages, you will be sending some sort of a message to the system, and that system or whatever object you're sending the message to needs to know how to directly handle that message. Okay. Which, in other words, it basically means that this is an object, the message that you're sending better be a method that this object already supports. Because if not, then there is, that object wouldn't know what to do with it. So that is really the most important thing that you can do as you build these sequence diagrams. You want to make sure that all of these messages are some things that the objects actually have support for. In the next video, we're actually going to do a real sequence diagram of an actual system with an object model that we create, so we know exactly what are the different messages that we are going to pass. Before I end this video, I want to show you one last thing. It's called an activity diagram. So an activity diagram is somewhat like a sequence diagram, but it's a little bit of a broader type of diagram. So instead of showing objects in a lifeline and showing every message that goes back and forth between the objects. An activity diagram is kind of like a use case, but you're actually showing sequences of the different activities. So instead of showing objects and messages, you're basically showing the blocks of code or blocks of actions that happen when a system functions. So here's an example of an activity diagram. So as you can see, these are just different blocks of the system. So executing an order, yeah, that's a block. You may have a sequence diagram just for that purpose, but for the activity diagram, you're taking these various blocks of sequences and you're showing kind of like a master sequence between them. And what is important to note here is that you can have branches, you can have sequences that happen in parallel, for example. So this is one example where sequences are happening in parallel. By the way, in sequence diagrams also, we did not talk about that in this video, but maybe I will do another video on this where you can actually display loops and branches in a sequence when that's necessary. Typically, though, in a sequence diagram, you take a look at a use case, and if the use case requires a branch or a loop, you will show that in the sequence, but the use case may only specify a specific branch that satisfies that use case. So typically a standard sequence works for most practical purposes, but sometimes you may have to show additional information like loops and branches. So that's basically all I want to talk about in this video. Sequence modeling is just to show a flow of control in a sequence. Remember that your objects are along the lifeline in the vertical line. You go time, so from top to bottom, you're increasing time, and the messages that go sideways, horizontally, are all going to be method calls and return messages from those method calls. If you remember just those three, you should be able to look at the sequence diagrams and understand how they function and create your own sequence diagram when you have a scenario of events for a particular design. So that's the last concept video that I wanted to do, and you survived it. So We're going to do a lot more builds and other types of um, actual system building for the rest of the series. So see you at the next video.